Hi class, I'm going to try to do some lectures on YouTube. We'll see if that works for you. I'm trying different methods and I'd love feedback on which thing works the best for you. So we're heading in from cardiovascular system, which you had last week, into the immune system, which is what we're doing this week. So when we talk about the immune system, it's really kind of broken into three parts. So I'm going to go through each one of those parts. I'm also going to put on D2L for you a little video that has, it's kind of a cartoon of the immune system. If it helps, then fine. If you don't want to watch it, you don't have to, but I'm trying to give you a big picture of how the whole system works. So the first part of the immune system is non-specific defense. So when I talk about non-specific, what I mean by that is that it doesn't matter what kind of organism is coming into your body's just going to attack it. So we often call an organism that comes into your body a microbe. And so when we call them a microbe, what we're talking about can be a bacteria, it can also be a virus, it can also be a fungi, because fungi can attack our body sometimes too. So when we talk about non-specific defense, then it's just something our body does to attack whatever it is, it doesn't care. So one of the first forms of non-specific defense then is barrier. So what I mean by barrier is our skin. And because this first week we're doing skin in lab, you'll have a little bit of that to look at with your different professors too. So in the skin, we have oil. And the oil actually kills organisms, very, very small organisms, but that oil on our skin helps to kill it, and also it's just a barrier to prevent things from coming inside. And we also think about our respiratory tract and what we have in our respiratory tract to help protect us. Again, it's not specific. Remember the mucus plus the cilia. So the mucus globs onto organisms, and then the cilia moves the mucus and the dead organisms out of your system. Then the last one is your stomach, in particular the acid in your stomach. And it can kill off organisms that we take in, because those areas, especially like our stomach and our respiratory tract, are open to the outside world. One of the other forms of non-specific defense is inflammation. So you might not think of that as a defense necessarily, but usually what happens is, you cut yourself. And when you think about what happens when you cut yourself, normally this is where I ask questions, I'll say, what does it look like when you have inflammation? And so what you would say would be, it's red, it's hot, it's swollen, etc. And all those things happen when we cut ourselves. So why is that happening to our system? If we think about it, what we're trying to bring in to that cut is our warriors to help protect us, because now we've opened up our system to the outside world. In order to get the warriors, which we're going to talk about in a second, which are these, to that cut, we have to bring everything there. We have to do it fast, and so we can't just bring white blood cells, which are going to protect us, to the cut. We also end up bringing all the blood, because the blood is gushing like, save the day, protect us. So now, as a side effect of bringing in the white blood cells, it's now very swollen because we have too much fluid. It's hot, it's red, it hurts. So one of the things you're going to do is to put ice on it. Why do you put ice on it? And often now they tell you put ice on it for 20 minutes and then take it off, let it warm up, put ice on it for 20 minutes again when you hurt yourself. So the reason for that is that you're stopping the blood for a little while and stopping that swelling, which is really painful, and it's hard on your system to swell. And then when you ease up on the cold, you allow new blood to come in, new white blood cells to attack again, then let up and keep doing it. So that's why they tell you to do that, and it is actually really useful to do that 15-minute ice and then take the ice off. Okay, before I get here, I'm going to finish off with the Nonspecific defense. So the last one that's the nonspecific defense, oops, on that C, is complement system. And the complement system is really interesting. So this makes you have to remember diffusion and osmosis from a long time ago. So a microbe enters the body, let's say bacteria, okay? And then a signal is sent to something called the complement protein. They become activated to attack the microbe. So what the complement proteins do, so here's our microbe, right? And it's like doing its little thing, like being naughty in our body. And so the complement proteins move in, and they're smaller than the bacteria, and they poke holes, little holes in the bacteria. And you're like, all right, so what? The holes are poked in the bacteria. Well, remember, it's in our body, and in our body we have water, or we can say solution. And so when we think about osmosis, because this microbe is, let's say, salty, and it's saltier than the water of our body, what happens is the water moves in to the microbe. So let's say this microbe is about 10% salt. And outside in our body, it's 1% salt. It's not as salty outside as it is inside, and so the water rushes in to try to equal things out. So you have diffusion and osmosis taking place at the same time. So anyway, what ends up happening is the microbe blows up. Okay, microbe blows up. I have been in quarantine for a while. Okay, so the next thing then is our white blood cells. So let's talk about that as a form of defense. So that's number 2, white blood cells. So normally when we talk about white blood cells, we call them WBCs. And if you can remember from lab, all of our blood cells are made in our bone marrow, our red bone marrow. And it makes red blood cells, white blood cells, and platelets. So if we think about white blood cells, not all white blood cells are the same. They're all different and they do different jobs. So when somebody has a high white blood cell count, I always want to know which white blood cells are the high ones because it matters. So for instance, we have cells that are called monocytes. They tend to be the largest. They have a very long lifespan compared to some of the other white blood cells, let's say 120 days or longer. And their whole job is to break down bacteria. So they get signals from the proteins. Remember on the cell membrane surface we had proteins. Proteins are constantly sending out signals, and they're sending out information to the other cells. So they send out an information, hey, there's bacteria in our body. The monocytes move in and they begin attacking those bacteria. Then we have neutrophils. Neutrophils tend to be the most numerous in our body when we look at the different kinds of white blood cells. And they actually will kill and digest bacteria and fungi. So we don't often think of fungi as being dangerous, but molds and different kinds of fungi can actually get into our system and cause problems. We also have eosinophils. The word eosin is kind of a cool word. Phil means to love, and eosin means the dawn. And so they're kind of a pinkish, yellowish color cell, so it means to love the dawn or the morning. And eosinophils respond to parasites. So most of us don't have very many eosinophils because they tend to be very specific. But if you came back from a different country that you'd been visiting, for instance, and you weren't feeling well, they'll look to see if you have a bunch of eosinophils because that can indicate that you've had a parasite. And then the basophils are another form of white blood cell, and they are common when we have an allergic reaction. Allergic reaction. So if you're having allergies, like right now, maybe you're having some allergies, then you'll have a whole bunch of basophils in your blood count, and that can indicate an allergy. All right, then there's one more kind of white blood cell, and it's called a lymphocyte. But I'm going to talk about it separately because the lymphocyte is involved in what we call specific immunity. So all of these other things are kind of responding to general organisms that are coming into our body. The specific defense, though, are these white blood cells that are going to help us remember a certain organism. And so they're very specific for what they're attacking. And these kinds of white blood cells are called lymphocytes. And in particular, we call them T cells. And each of the T cells have a different job. So for instance, you have a memory T. And the memory T cell is the one that's going to recognize the invader. You have a helper T. And the helper T, its whole job is to stimulate the killer T. Then you have a suppressor T, suppressor T cell, and its whole job is to stop the killer T. And then finally, we have our killer T cells. And the killer T cell's job is to destroy the antigen. Now, what's an antigen? Okay, so let's go to that. So a microbe is an organism, and an antigen is basically, it's the outer coat of the organism that's an invader. So we're going to call it the invader with a weird cell membrane that helps our immune system recognize it. So when we talk about vaccines, for instance, one of the things that we do, so let's just talk about vaccines. What are vaccines? So vaccines are treated microbes. Okay, they are no longer virulent. Virulent. What does virulent mean? Virulent means they do not cause us harm anymore. So they'll go in and they can even take the guts out of the microbe and just have the shell with the cell membrane. And remember the sugar chains that came off of the cell membrane. So that's the thing that the memory T's are going to recognize. So when we have a vaccine and we inject that into our system, our body then starts the process of doing the memory T's, and the helper T's then send out a signal to the killer T's, go and kill this organism. Killer T's go and start killing it off, and then the suppressor T's are like, okay, good, you can stop now, you've killed off the organism. And so what also happens with the vaccines, or the memory T's, what the memory T's do is that they produce an antibody. And an antibody is like a protein signal. And that protein signal helps us to remember an organism and whether or not it's come into our body. So, when we get a cold virus, for instance, and coronaviruses are cold viruses, basic cold that we always get, when we get a cold virus, our body begins to recognize it, it responds, it begins killing off the cold, we've killed the cold, we'll never get that cold again because our memory T's are going to remember it and say, okay, we've had this before, now we're not going to get sick. But the problem is those organisms, viruses and bacteria, are constantly evolving and changing, and so Now we have a new one, and our body's like, oh, we don't know this one, and you get sick, it gets its memory going, that whole system happens again. One thing that's important about this is that this particular system takes 2 weeks in our body to happen. Now, why that's important is that some people will go and get a flu shot. I have a student who I know that went and got a flu shot, and then he got the flu. Well, in part, for a couple reasons that can happen. One is that he got the shot and then within that 2-week period got the flu. So his body hadn't set up that immune response yet, which is why you should get a flu shot early. The other thing that can happen is, again, that flu virus can mutate a little bit. So while he got the shot, that flu virus was slightly different and he got sick. But the good thing about it is that he wasn't as sick as he could have been if he'd had full-blown flu. All right, so when we talk about vaccines, we call this active immunity. And it's active because we've activated it. We've made it a very active way that our body can respond. We also can do things like boosters. So many of you have had boosters. If you can think about one, it's probably tetanus. And tetanus is an important booster. I often talk about it because it's a serious disease. It causes a lot of deaths in the world. There are about, I don't know the exact number, but let's just say, I think it's like 100,000 deaths per year from neonatal tetanus. Neonates are brand new babies. And when you have tetanus, one of the nicknames for tetanus is lockjaw. And the reason they call it that is because the tetanus bacteria gets into your system, and what it does is it causes all of your muscles to contract as hard as they can. So think about like a Charlie horse in your calf and what that felt like and how much it hurts and how hard that calf is when that happens. With tetanus, your entire body goes into that kind of a contraction. And it's so forceful, your back breaks, your jaw breaks, your arms break because your whole body is contracting. So imagine a newborn baby that's going through that. It's really quite terrible and horrific. Now, how can we prevent that? Well, vaccinations are one way to prevent tetanus. And why do neonates in the world get that? Largely it's in places like the developing world where you have midwives or a shaman in the village that delivers the babies. And unfortunately, what they tend to use are things that are tradition, like the same piece of metal or the same piece of glass. They use that to cut the umbilical cord when the baby's born. And when they do that, they introduce that bacteria into that baby. So there are a lot of people that work for like the Peace Corps, for instance, or Doctors Without Borders that go to other countries, and they teach them we have to sterilize these things before you cut the umbilical cord. And they're trying to prevent some of those things from happening in the rest of the world. Okay, so that's active immunity. We also can get passive immunity. To have passive immunity is when a newborn baby gets immune cells, T cells, from the mother in two places, from the placenta and also from the milk. So when that newborn baby is drinking mother's milk, it's getting some of that immunity from the mother. So this is really important. You should never take a newborn baby out in public until they're over 2 months old, because they don't have immunity like we do. And so they are very susceptible to any kind of organism that's out there. And so really they say wait until 2 months before you begin exposing that baby out to the mall or to other places, because it's really hard on their system. They don't have a way to protect themselves. And then the other thing I wanted to mention was immunosuppressed. versus autoimmune. So if we think about immunosuppressed, this is somebody whose immune system is not working well. So this is people that have had chemotherapy because maybe they have cancer. So we suppress their immune system so that we can go in and try to kill the cancer. Also people that have AIDS, their immune system basically doesn't work very well. And so those are people who are immunosuppressed. When we think about autoimmune, and this is kind of interesting, one of the things about autoimmune is that an organism can move in. For instance, let's say you have a cold. It's kind of a weird cold, like coronavirus, and your body begins responding to that virus. But for whatever reason, your suppressor Ts maybe aren't stopping your killer Ts. Or maybe your killer Ts refuse to listen to the suppressor Ts, and they keep going, and they keep hammering after those normal body cells and destroying them. So a classic example of that is multiple sclerosis. Multiple sclerosis, or MS. And it affects the nervous system. And in particular, people that have MS, one of the first ways they notice that they have MS is they can't see as well, because their body begins attacking their optic nerve. Then the body will attack the brain, it'll attack the spinal cord. Somebody who could hold a cup one day, they drop it the next day because their body's being attacked. So that's your own body kind of attacking itself. Some other examples of that would be lupus, rheumatoid arthritis, where it attacks the joints. And there are several others. I will post a list of all the autoimmune diseases so you can see all of those. Okay, the last thing I'm going to talk about are allergies. And how are allergies different than all of this? Because many of you may be experiencing some of these allergies. So, when we think about allergies, we have something that's called an allergen. That is a substance that causes your immune system to overreact. So when somebody has an allergy, it's not that your immune system isn't working, it's not immunosuppressed, it's that your immune system is working too hard and it's trying to attack things that are perfectly harmless. So an example of different kinds of allergens are things like pollen. People can have food allergies, things like shellfish, nuts, berries. Lots of people are allergic to all different kinds of foods. Insect venom, cosmetics, metal, certain kinds of drugs, like penicillin, for instance. People can be allergic to that. Fungal spores. So fungus or mold send out spores, and sometimes our body will react to that. Now in Grand Junction, we're fairly dry. We don't have a lot of problem with fungal spores. One thing that's kind of gross is cockroach feces. So if you live in a place where you have a lot of cockroaches and they congregate, they poop a lot, and so people can actually develop an allergic reaction to cockroach feces, which is very nasty. Dust mites are another example of different kinds of allergens. So there's so many of them out there blowing around, and when our bodies take them in, for whatever reason, in some cases, we overreact. So if we think about how that happens inside of our system, the body begins to make a certain kind of antibody, and the body being the memory T. It makes an antibody, and it tries to tag the pollen. So, okay, we get this pollen again, we're going to remember it and we're going to fight it. And so it's kind of crazy because the particular antibody that it's tagging is called an immunoglobulin protein, which is also known as IgE. And so it tags the allergens with IgE. One of the things they'll look for when somebody's having an allergic reaction, if they want to try to determine that, is do you have a lot of IgEs in your body? That means that you're allergic and your body's kind of gone crazy. Then the antibodies, the IgEs, will attach to a cell that's called a mast cell. And when we think about where the mast cells are, they tend to be in our respiratory tract and in our GI tract, so our digestive tract. Because remember, both of those places are open to the environment, and organisms are always coming in. So mast cells, their whole job is to sort of send out the alarm when the body's being attacked. So if these IgEs attach to the mast cells, what the mast cells do then is the mast cells explode, and when they explode, they release histamines. And histamines cause inflammation. So if we go back to that original part where inflammation, we don't want inflammation, but it's a way to bring in the white blood cells to attack the invader, that's what's happening. So when you think about an allergic reaction, what do you take? You take an antihistamine so that you can stop that whole inflammation process that's crazy going on in your body. And then the last thing I will mention is just anaphylactic shock. So when somebody goes into anaphylactic shock, what happens with that is the body responds very dramatically to an allergen. So for instance, things that can cause anaphylactic shock are like bee venom, latex gloves, for instance, shellfish. Those things people tend to respond very dramatically to. And when they respond to it, the heart dumps all the blood out. Because why? Because of histamines. It's sending out inflammation. Well, you can't have no blood in your heart because now blood's not getting to your brain, it's not getting to your cells, and the whole system collapses. So in order to prevent that from happening, what most people that have this situation carry around with them is an EpiPen. And an EpiPen is epinephrine. And what's epinephrine? Epinephrine is adrenaline. And so what adrenaline is going to do is it's going to bring that blood back and get the heart working again. And so it's a way to stop the whole dumping of your blood everywhere else, but allows that blood to come back, and it allows the doctors and people to take care of you if this is what you're going through. Okay, so that's pretty much it for the immune system. Take some notes. I'm going to have a little video that goes through this in a kind of a little cartoon way, and I'm also going to put up a PowerPoint that has pictures of the different cells and the different things, so you can take a look at that. And then at the end of the week, you can watch a movie. It's called Calling the Shots. It's a great movie, and it's very pertinent to what's going on today with the coronavirus. And I welcome any questions that you guys have. Make sure to send me any questions. You can either text me now with that phone number that's in the Begin Here module, or you can send me an email, ask me questions, and I'm happy to answer them about coronavirus or about any other viruses or autoimmune or whatever else you may have. All right.